It's not a fill-in thing. It's a watch the video and take it on notebook paper thing.
You guys, we might be killing baby animals, but you're killing the trees.
It's true. It's true. But it's for learning. It's for learning, so it's a noble cause. So, all right. So the around the room activity you keep because I watched and I could see that everyone was fully participating. So whether or not you finished, you got all the points. Okay. So here is our next example problem. If you want to put a new heading, that's fine because we are still completing the square as our process, but these problems are slightly different. So if you wanted to write that this is completing the square, so we're still converting quadratics into vertex form. The process that we're using is still completing the square, but this time a does not equal 1. So that means x squared is not by itself. Yeah. So we're going to do 2x squared minus 16x plus 33. You cannot slide divide. So sorry. So sorry. So what we're going to do to start with is we're going to move the 33 over just like before. So first step is exactly the same. Move the 33 over. Do I need to zoom in more? I can zoom in a little bit more. Okay. So what we do next is we factor out 2 because we want the x squared to be alone, and the 2 is what's keeping it from being alone. So I'm going to keep the y minus 33. I'm going to factor out the 2, and that's going to leave me with x squared minus 8x plus blank, and then I'm going to end my parentheses. So it's adding a slightly different step than what we did before. Okay, so now we do the same thing as what we did before. So we already did something a little different, but now it's a little bit the same. So we've got negative 8 divided by 2 is negative 4. Negative 4 squared, don't kill any otters, equals 16. And I'm going to add 16 because that completes the square. However, I didn't actually add 16. I actually added 2 times 16. What's 2 times 16? 32. I actually added 32. Because this side is actually 2x squared minus 16x plus 32. That's what it actually is. I just have that 2 factored out. So we did negative 8 divided by 2 is negative 4. Negative 4 squared is 16. Completed the square with 16. However, we have a 2 in the front. So we actually have 2x squared minus 16x plus 32. That's what we actually have. So what I did is I said, since I added 32 to the right side, I'm going to add 32 to the left side. As you can imagine, this is the step that most students will forget to do, right? Okay. So now I'm going to say this is y minus 1, right? Because negative 33 and positive 32 equals, and I do have my parentheses squared just like before, but this time I have a 2 in front. We didn't distribute it. I showed you how it worked, but I left it in the front, right? Okay. Now, x squared minus 8x plus 16, if I was to factor that, I would get x minus 4 times x minus 4, right? 2 numbers that multiply to 16, but add to negative 8 would be negative 4, negative 4. So just like before, we're going to say whatever number I got when I divided by 2, that's the number that's going to go inside the parentheses, just like before. So the only part that changed was this part right here, was that we factored a number out in the beginning, and that number messed with things a little bit in the middle of the problem. Okay, and then what do I do to finish it? Add 1. So the 2 in the front of the original problem was actually a prediction for later that we were going to have a vertical stretch of 2. So the 2 in the beginning of the problem was still a 2 in the beginning later. So these are vertex form, but now we're going to have stretches and compressions and reflections over the x-axis because now we've got a number on the front. Okay, we're going to try one that feels like it's not a situation where a does not equal 1, but it technically is. So we're going to say y equals negative x squared plus 6x minus 5. Negative 1. So it feels like the x squared is kind of alone, but it's not because it's got that negative in the front. All right, so did you say just like your emotions? That's weird. Okay. Bless you. Bless you. It's almost Valentine's Day. Things will come together, I'm sure. All right. All right. What do I do first? Not the negative 1. The 5. Okay, we're going to move the 5 over just like we did last time. So y plus 5 equals negative x squared plus 6x. Now, students always, especially on things like this where we have there's a fair amount of work to show, right? Students on this will start skipping steps and then they'll start getting them wrong. So, you are not allowed to skip steps until you've gotten 10 right in a row. Once you get 10 right in a row, go ahead and start skipping. But if you're like, yeah, I got 1 right, let me start skipping steps, that's a great way to start doing it wrong, okay? So do not skip steps until you are brilliant. Marvelous. Okay, what should I do next? Take out the negative. So I've got y plus 5. I take out the negative, which leaves me x squared minus 6x plus blank. And then I've got negative 6 divided by 2 is negative 3. Negative 3 squared is 9. 9 is the number that completes the square. But I didn't really add 9. I actually subtracted 9. Isn't that weird? Because I have to think about that negative in the front that's being distributed. So this is actually a negative 9, so we're actually subtracting 9 over. So you just have to be careful. So if we think about this with the negative in the problem, it would have been negative x squared, positive 6x, negative 9. That's what it would have been if we hadn't taken out the negative, right? So negative x squared plus 6x minus 9 is what it would have been. Okay, so now we have y and some number equals negative parentheses squared. Okay, negative 4 in the front, that was 5 minus 9 is negative 4. What goes in the parentheses? X minus 3. Okay, and then what do I do? Add the 4 over. So just like before, for that first example, there was a 2 in the front of the beginning of a problem, and so there was a 2 in the front of our vertex form. There's a negative in the front of the beginning of the problem, and now there's a negative in front of our vertex form. Okay. All right, let's do another one. Y equals negative 2x squared plus 12x minus 17. I know I gotta zoom in when I start getting the squinty faces on the back. They're like little chipmunk faces. All right, so what do I do first? Add the 17. Okay, I'm going to go kind of slow on this one. See if you can stay one step ahead of me. So see if you can predict what I'm going to do next. Okay, so we added the 17 over. Yep, we're going to pull the negative and the 2 out. We keeping up okay? All right. And then divide by 2, square it thing. And then I say, but I didn't really add 9. Number 3, we can do it. Ready? All right. What is the first step? Add the 4. Okay. All right. Then what do I do? Take out the half. Okay. Y plus 4 stays the same. I have to divide out 1/2, and I have to understand how dividing by a fraction works. This is kind of like saying if I do 3 divided by 1/2, it's kind of like saying how many half cups are in 3 full cups if you were like cooking. So how many are there? 6. The number gets bigger. When you divide by a fraction, your number actually gets bigger, not smaller. So 3 divided by 1/2. Now, if you want to see the work for that, we would say 3 divided by 1/2. I don't know how your probably middle school math teacher phrased this, but I always say keep it, change it, flip it. So, yeah, keep it, change it, flip it. So 3 times 2 over 1, which is 6. So 3 divided by 1/2 is 6. When you divide by fractions, the number gets bigger, not smaller. Keep, change, flip. So keep the top number, change it to multiplication, flip the bottom. Okay. They might have said keep, change, change. Yeah. All right, so if we look at this, what do we do next? Divide by 2. 6 divided by 2 is 3. 3 squared is 9. But I didn't really add 9. I did not add 18. I added 4.5. Yeah, I didn't really add 9. I added 4.5. Don't subtract 4.5. Add 4.5, because you're keeping the sides balanced. So if you added 4.5 to the right, you should add 4.5 to the left. Okay, so I have y plus something equals y plus 8.5. X plus 3 squared. We are missing one little thing in there. the 1/2 in the front, okay? And then minus the 8.5 over. So, Carter, if you do, in your calculator, if you do 3 divided by 0.5, makes it bigger, not smaller. Yeah. All right, now the instructions, if you look at the instructions, they said complete the square. They said complete the square to get each of the following quadratic equations into vertex form, and then what did the instructions say? Find the transformations. So, what are the transformations? Compression by 1/2. Okay, vertical compression of 1/2. What else do we have? Left 3. Down 8.5. Okay. Man, that was so fun. All right, should we do another one? Number 8. All right. Yes. We are not scared of these fractions. They're going to be great. No, we're not scared. We know they're going to be great. We know they're going to be great. Because we know how fractions work now. They make the number bigger, not smaller. So now that we know how it works, we can do it. Okay. So what do I do first on number 8?
Minus 35.
Yeah. Okay, so we're going to minus the 35 over. You have to write very small because I decided on this assignment to try to not kill as many trees. The Lorax. Yeah, I can't shield you from that. This is like upper level math, so the ink is gonna happen. All right, what do I do next? Kind of divide out 1/4, right? So, how many 1/4 go into 6 holes? 24, yeah. Minus 24x. So, if we were to show our work with that, -6 divided by 1/4. Keep it, change it, flip it. Yeah. -24. Okay, so then I've got plus the blank. Okay. Yeah. All right, so -24 divided by 2 is -12. -12 squared is 144. But I didn't really add 144. I added less. I added 36 because 1/4 times 144 is 36. So I really added 36. Okay. I mean, you are going to subtract it eventually, just not yet. Okay. And then put the 1 over. Okay, and we put the transformations, which are, okay, vertical compress by 1/4, right, 12 down 1. Whew! My brain feels good. Yeah, these are, once you do enough of them, it's like in your brain. Now, what I've noticed is that students by test day tend to block these out. So make sure that you find a good one or a good 2 or 3 and put them on your cheat sheet for sure. Because these seem to be the ones that by test day students are just like, nope, done. Those are terrible now, okay? All right, so let's go ahead. We got about 10 minutes. Let's see what we do in 10 minutes, and then I'll let you guys know what the homework is. Well, we only have 10 minutes left in class. And I told Cam he could, but I've been trying to follow that rule, actually, this whole time. Yeah. Sorry. Yeah. Yeah. So, we're all going to hold it for 10 minutes. Okay.